Alrighty guys, so for class today, we started taking some notes, but we kind of didn't get through all of them. So I'm going to have the video here for you. It's going to be maybe a little weird because it's not in my notebook, but I just don't want to write on top of your notes. I want to go through it with you live. Okay, so we have our table of contents here. On this first line, what we're talking about is order of operations, number types, number properties, and words to math. And we're going to be doing that on pages 1 and 2. So kind of a lot, but a lot of this introductory sort of like algebra rules, some of it is not super necessary to being a good mathematician. Obviously, order of operations, super duper important to understand how to be a good mathematician. And being able to read a problem and understand the math that I should be doing is super important. But number types and number properties, these things are valuable, but we more so just know them in the back of our brain, and we don't need to know necessarily the words for them, but we're still going to talk about them because it's kind of fun and important. So if we turn to our pages 1 and 2 in our notebook, if you remember in class, page 1 was a little strange. Okay, we had the little trifold around this one. And then page 2 is the one with the order of operations at the top. So let's start there. So with order of operations, we want to know that that is the type of problem we're doing. So reading directions is super important. Sometimes I notice that students will just jump into doing their math and not read what the directions want. So when I read the directions, I'll know that they want me to perform the order of operations if it says the words evaluate or simplify. Okay, so those types of words tell me that I should be following order of operations. Chances are, if it says evaluate, I'm going to be looking at a problem with all numbers and symbols, and I'm supposed to combine them all up until I end with one single number. If it says the word simplify, chances are I'm going to be looking at a problem that has some numbers and some letters, and maybe I can only combine up some of them, and I won't end up with one single number. I might still be left with a number and some letters not fully combined down into one, and that's okay. But maybe they additionally tell me that a letter is equal to something. So if I am looking at a problem with a letter in there, and maybe in the directions it says x is equal to 2, then the first thing that I might want to do before I start following my order of operations is to substitute. Now this only happens sometimes, like I said, if it specifically says x equals a number, then we're going to want to put that number in, and it could give you multiples as well. It could say x equals something and y equals something, so you're substituting multiple things in. But you put the numbers in for the letters so that then you can simplify it all the way down to just one single number. So the order that we must do that so that we all arrive at the same answer is we want to follow Pemdas, or sometimes Gemdas. So P or G are our parentheses or our grouping symbols. So we're looking for parentheses and grouping symbols, and whatever is inside those I need to do first. So we have our generic parentheses, but also the square ones are also low-key parentheses. The curly Q ones, which end up kind of just looking like a little bit of a squiggle. Also, absolute value bars are sort of low-key parentheses. Anything inside of those, you need to do that first, which might mean you have to reevaluate the order of operations again. If you look inside the parentheses and there are more parentheses, then you go inside that set, and you might have to reconsider after that. So the next thing that we're looking for are exponents. And exponents mostly don't come in weird varieties. It's mostly just little baby numbers, so x to the second, or maybe x to the 1/3. Ooh, you could have a fractional one. But one sort of low-key exponent thing is a root. So the square root, or that one that we talked about last week, a cube root. Okay, so those are sort of low-key exponents also. So those need to be evaluated before we get to some of the other things, which the next thing we're looking for is multiplication and division happens at the same time. So we want to evaluate in order from left to right. Like we're just reading through a normal sentence. Whatever comes first, we want to do first, and whatever comes second, we want to do second. So that doesn't necessarily mean multiplication happens first. They happen at the same time. Multiplication mostly looks like what you would expect. The only sort of weird multiplication is when we have a number smushed up against a letter, but that is multiplication. And then maybe some weird division would be something like a fraction bar, but that is division. We mostly don't use the one with the bar with the little dotties anymore. And then the last thing that we have to look for to evaluate is addition and subtraction. And again, it's advised to do it from left to right, but you don't really have to. As long as you take the sign in front of it, you can kind of do it in any order you want. Again, just being careful to take the sign in front of it. On to the next. So hopefully we generally understand the rules that we follow for order of operations. We've been doing a lot of practice with that last week, and we will continue to practice that through the year. But let's talk about number types. So when we think about all the numbers, like there's a lot, they can be split up into categories, sort of like English words can be split up into categories. Like there are nouns, and there are verbs, and there are adjectives. And I mostly forget the difference between all of those. And the same is kind of true for numbers as well. They can be split up into categories, like nouns are nouns and verbs are verbs. Numbers are a certain type of number or a different type of number. I mostly forget, though, because I just use the numbers as I'm supposed to, and that's kind of okay, but we still want to talk about it. So all the numbers that we can think of are real numbers, but they're split up into two categories. Kind of the larger category are rational numbers. And if it's not a rational number, then it's irrational. Like ir is sort of the opposite of. So irrational is not rational. And so talking about those two really quickly, a really, really famous irrational number is pi. And that's because pi is a number that does not end and does not repeat. So it's a decimal that continues forever, and the numbers don't start repeating themselves ever. Now, another really good type of number that is irrational is something like the square root of 7. And the reason for that is if I try to take the square root of 7 in my head, I definitely can't do it. I can bring it up on my phone and take the square root of it, which I am trying to right now, but I'm having a little bit of a struggle with my phone. We're going to get there. If I take the square root of 7, my calculator will do it, but you can see it's a real nasty decimal that seems like it ends, but it actually really doesn't. Your calculator just can't go on for infinity, though. So it's showing you as much of that decimal as it can, and you'll notice it doesn't repeat, and it will go on forever. So square roots that I can't do, like another one would be maybe the square root of 11, are all really good examples of irrational numbers. Now, rational numbers are numbers that do end or repeat. And so maybe a good example of that right off the top is something like 0.6 repeating. That's a decimal that repeats forever. Or something like 3/4, 3/4, that is a decimal that ends. It's 0.75. I just kind of prefer it as a fraction. So really rational is fractional, and anything can be written as a fraction except for irrational numbers. Now the next type of number that we get that excludes some of these weirder numbers like decimals and fractions are integers. And integers are mostly numbers that you like to be dealing with, aside from maybe negatives. So integers are like -3, -2, -1, 0, 1, 2, 3, forever in both directions. So we kind of just exclude all this stuff in between the numbers, and it's just the really nice whole numbers that are positive and negative and 0. Now the next numbers that we like to get rid of are those negative ones. And so whole numbers are next. Whole numbers exclude the negatives and start at 0 and just go positive. So 0, 1, 2, 3, forever, forever. Whole numbers do include 0, and kind of the way that I remember this, because it's a little bit funky, is like whole has sort of a 0 in it. Because the last set, natural numbers, kind of feels the same as whole numbers. They just get rid of 0. So natural are like 1, 2, 3, 4, 5, forever. They just cut off the 0. Because sometimes we don't want to consider 0. He's kind of funky. Last sort of mathy topic that we have here that's not super duper important are different properties of real numbers. So again, these are things that we sort of just understand and do, but they do have names, and that's kind of fun to know. I don't want to talk about closures, so we can cross that one right out. But the commutative property, commute means to move. So the commutative property of addition looks like 2 plus 3 is equal to 3 plus 2. So I just changed the order that I added. And that could be maybe worth it because, I don't know, maybe it's easier to add in the other direction for some reason. Usually this happens with more than just 2 numbers. But same is true for multiplication. So if I do 2 times 3, same as 3 times 2. I can add or multiply in any order that I choose. The same is not true for subtraction and division, though. This is only for addition and multiplication. Another one that we have for addition and multiplication is the associative property. So this is the one with parentheses, where it says, like, I could do 2 plus 3 plus 4, and that would be the same as doing 2 plus 3 plus 4. Now, I kind of ran into multiplication there a little bit. Multiplication behaves the same way, so I'm not going to rewrite a different example. But a couple things to notice. The number order did not change, so I didn't commute anything. I didn't use the commutative property. The only thing that changed is who I grouped up with, who I associated with. Over here, 3 and 4 are associating together. And over here, 2 and 3 are associating together. And we might do that because maybe it's easier for me to get 7 and then 9. Or maybe it's easier for me to get 5 and then 9. But either way, it's 9. So however you choose is good. The identity property wants to keep the number the same. So if I'm the number 7, I want to add something to that, but I want to stay 7. And so the only thing that I can add to stay 7 is 0. A little bit different for multiplication, though, because if I have 7, I want to multiply by something, and I want to stay 7. I want to remain my same identity myself. This time we need to multiply 1. Our next property here, so identity, like I want to stay the same. I want to keep my identity. Inverse is like opposite. So inverse in addition is like if I start as 7, I want to add something to it to completely like get rid of it. So the thing that I would have to add to it to get rid of everything is -7. So like 7 and -7 is 0. If you think inverse operation, this will make a lot more sense. And with multiplication, it's a little bit funky as well. So if I start with 7, what do I need to multiply by to actually be 1? So I don't want to go to 0 with this one. We want to go to 1. And so that's a little bit weirder. I actually need to multiply by 1/7, which is kind of like just dividing by 7, which is what we want to do because 7 divided by 7 is 1. Last property that we have here is the distributive property. And so the distributive property could look something like 4, parenthesis, 2 plus 9. Now, generally, I would advise against the distributive property on this one because we could just do what's in parentheses first. But if I replaced the 2 with an x, then I kind of can't. And so then I have to do the distributive property, which just takes a number outside parentheses and multiplies it to both the numbers inside. So it's kind of a property of addition and multiplication. And so we get 4x plus 36. Lots of information. We want to take a look at the other side too. So a couple of things to mention. Firstly, we had this weird like tri-foldy thing. Now, there was nothing to fill out really on this one, but I do want to point out there's a lot of good mathy words on here. So like this whole box is all words that mean addition. So a really good one is maybe sum. Another really good one is and. Minus over here, like difference of, less than. Those are all really good subtraction words. Parentheses or multiplication words, we got product. That's a really good one that a lot of people forget. Division, okay. Another good one for division that a lot of people forget is quotient. And then if I need to add parentheses in my problem, you're going to notice either one word, like the word quantity, means I should have parentheses, or you're going to notice that you have like two mathy words sort of back to back. So like twice the sum, I have like two mathy words back to back, no number in between. So that really means I need to put parentheses. So like times parentheses plus, or like plus the difference of would be like plus parentheses subtract, or like times the difference of would be like times parentheses minus. Now the turnaround words are real good. They are also subtraction words, but I need to swap the order. So what I mean by that is if it says something like 5 or 4 less than x, it's super tempting to just write that right in order, but you got to turn the numbers around. So it's actually going to be x minus 4. So like we swap the order. These are all really good equals or inequality type words, and those are just there for you to use. So on the inside of this one here, we just have some practice problems of like changing like an English sentence to like a math sentence. And these are all just different examples. Now guys, I don't want to make this video too long, so I'm just going to do like the top 2. And I can also link the Algebra 1 video that has all of them if you guys are interested. So for example, twice a number divided by 2 is -9. I kind of go through and read it real slow, and then I just interpret as I go. So twice is like 2 times some number, don't know, we're going to call it m. Divided by, I'm going to put big divided by, 2 is a really good equals word. It's like the best equals word ever. -9. And the tempting thing to do here is to solve it, but you don't have to solve anything. You're just trying to write out what it says in math. And so sort of the reverse of that is if we're looking at a math sentence and we want to write it out in words, you can really choose how fancy you want to get with it, like how sneaky and fun you want to get with it, or you can just be super straight. Like this, if I'm going to go super straight with it, I see 12 minus 2 times x is 5. Super straight and easy. If you want to get some crazy words in there like product instead of times, or difference instead of minus, or yields instead of is, that's all good, but like you can just be straight with it too. All right, so if you guys are sort of struggling with this, don't worry. We're going to practice this so much this year. Like story problems are going to be my favorite thing ever. And again, I'll link the video if you do want to see more examples of these, but I just don't want to make this super long just in case. So hopefully that went well, and I will see you tomorrow.